Alfred. Alfred. Okay, so everybody, welcome to today's lecture. This lecture is actually a concluding part to the already recorded lecture. I have already sent you the link to the main lecture for this topic: cost volume profit analysis, single product assessment. This part of the video is to show you how we will do the same kind of assessment using spreadsheets. So that's the concluding part of the lecture. The main lecture is already recorded. I've already sent you the link. It's on your YouTube channel, and I'll send a link to the YouTube channel to your Google Classroom platform. I've also sent same links to your course reps, so I understand they will distribute them to your other platforms. Okay. So I'm going to give just an overview of cost volume, profit analysis. Since the lecture is already done, I'm just going to give an overview. I'm just going to do a review of it so that we kind of bring ourselves to speed and link our understanding to how the same thing is done with spreadsheets. Right. So with CVP, this is just what we want to do. Excuse me. First of all, afternoon. Who you announced it? Okay. No, he has only finished with the distance. David. Yeah, gotcha. Ewo Fusuana. Gotcha, Martin. Namanako. Friday, Martin. Memphis Namanako Friday. Okay. Martin Senior. Yeah. Yes, boss. Martin. David. Martin Senior. Memo was what me were lectures is here, maybe I miss free, but that's okay. Sorry. So with CVP, what we seek to do is to get an understanding of how the cost structure of our business and the volume, the number of units of the products we produce impacts on our profitability. Because if you're able to get that linkage, every organization will produce with a certain cost structure. You will have a certain amount of fixed costs, you have a certain amount of variable cost. So with that cost structure, this assessment, or we should have a way of understanding how much do we have to sell of our products, given the cost structure we have, to make certain profits. So we normally begin the assessment from, with a given cost structure, how many of the products we produce and sell should we produce and sell to, in the first place, break even, pay all of our costs with zero profit. Then we extend the analysis to knowing how much of the products or how many of the products do we have to sell to make some target profit. So that's the basic kind of assessment we want to do with CVP. And it's very, very interesting thing to note. And it's a tool that I think all businesses, whether big or small, needs to have. It should be in your toolkit. You need to employ them every day in your assessment to kind of gauge if you have this cost structure. I mean, how much work should you do to break even? How much work in terms of sales should be done to make certain targeted profit, and so on and so forth. Okay, so all of these analyses are in the main lecture. I've already sent the lecture. The lecture is already recorded. I've sent you the link. Cost volume profit analysis. For your level, we are going to end with single product analysis. There is a multi-product assessment, which is a little bit complicated, but we are not going to bore you with those complications. Rhoda, Rhoda. Okay, so that's the overview of CVP. That's what we seek to do with CVP. So if you watch the main lecture, you will come to the understanding of certain formulas. We begin by saying that in a business, the profit that we want to make is a function of our total fixed costs and sorry, let me take that one again. The profit we want to make is a function of total revenue, which is sales, total sales revenue. So sales revenue minus total fixed costs minus total variable cost. Total fixed cost minus total variable cost gives you your total cost. So if you subtract all your total cost, which is total fixed cost and total variable cost from your sales revenue, from your sales revenue, you get your profit. All right. So we want to do the analysis step by step. If we are seeking to pay all of our costs and get zero profit, what is the volume that we should produce? What would the formula be like? This is the main formula, but this formula can be broken down into pieces. The formula that can get us the quantity that we need to produce and sell if you want to just break even. The quantity that we need to produce and sell if you want to make some profit in mind. The sales revenue that we need to generate if you want to break even. The sales revenue we want to generate, we have to generate if we want to make some targeted profit, right? So this is the generic formula. And you can see how this formula breaks down into the various formulas that we will use to do this analysis. That is in the main lecture. I don't need to repeat that lecture. Okay, this is supposed to be a follow-up. The main focus of this lecture is to kind of introduce you to how we can model this whole analysis using spreadsheets. Right. So basic things that we need to understand. We understand that our total revenue is equal to the quantity that we have sold multiplied by selling price per unit. Total fixed cost, it is always given. It's a fixed amount. It is not derived from any two variables. It's given. Total variable cost is derived from quantity multiplied by variable cost per unit. Right. If we are able to capture these key input variables, then we can model any situation. We can model any cost structure and quantities that will give us a sense of when we will break even, when we will make certain profits along the line. That's what we want to do. So let's go straight to Excel and see how this is done. For you to get the full benefit of this lecture, you must have already watched the lecture ahead of this one. And the link of that lecture is already sent to you, which is a full video recording on cost volume profits analysis single product. Watch that one, then follow it up with this video. Okay. So if we capture our key input variables, if you capture our key input variables, which is selling price, and we have our quantities, so let me kind of remove all of these things. Okay, so this is the price at which we are going to sell the product we are dealing in. This is the given variable cost per unit, and this is the given fixed cost. So with this given cost structure and given sales revenue per unit, how many units of the product? So this is the quantity. How many units of the product should we produce to make profit zero, to break even? So it's not surprising that most people refer to cost volume profit assessment as break-even analysis, because that's a starting point. We first want to know how much, given this cost structure and this selling price per unit, how many of the products should we sell so that we're able to pay all of our costs, break even. And we later look at making supernormal profits. Okay, so this is how we do the modeling. Every modeling, this is how we normally structure it. These are the key input variables, and the lower section is the main model. So this is the selling price per unit. The key input variables are the variables which from time to time you may want to change and see the impact. What if the selling price is not 100 but 80 Ghana? What will be the break-even point? What will be the break-even quantity? What will be the break-even revenue? And so on and so forth. So we capture the key variables like what I've done. That's what every good model does. Variable cost per unit is a variable that we may want to change from time to time and see the effects on the bigger picture. What if variable cost per unit is not 60 cedis, but costs increase, so variable cost per unit becomes 80 Ghana cedis? What will be the impact on our profitability? So with this new change, what quantity do we have to sell to break even, to make this profit, to make that profit? What if fixed cost is not 20,000 as I've captured here, but fixed cost is 15,000 because we're able to work how to reduce some fixed costs? What will be the impact on our profitability? You want to see all of these things. So that's why you have to do the modeling like this. So we have captured the key input variables. So we are trying to bring in some candidate quantities, 0 up to, so a range of quantities, 0 up to, it can be 1,000, 0 up to 1,000 in steps of 10. Okay, so the common difference is 10. So we can even extend it to 1,000. Yes. Let's say we are a medium level company. So this will be 1,000. Yeah. So 1,000, 0 to 1,000 quantities. 0, 10, 20, 30, 40, up to 1,000. Given this revenue per unit, how much revenue, how much total revenue would we make across these quantities to be sold? And you know this basic formula. This is equal to the quantity times the selling price per unit. And this selling price per unit, because of how we have captured the input variables, that sale should be converted from a relative sale reference to absolute sale reference. And I've already talked to you about how to do that. So in case you don't remember, you can just Google and find out how do I convert relative cell reference to absolute cell reference. Very simple. The information is in your palm. So I press enter. So it's a formula. Revenue is equal to selling price times quantity. That's just what I did. This is the quantity, 0 multiplied by selling price per unit. The only thing that is a little bit different from what you know already is converting this cell reference from relative to absolute. And I've already explained to you. So the rest for me to do is to drag across all the quantities that we are using for the model. So up to 1,000. All right, so this is the sales revenue across all the quantities. So sales revenue when we sell 1,000 units will be 100,000 because selling price per unit is 100 cedis. Okay. Total variable cost. Total variable cost, you know the formula. Total variable cost is equal to quantity times variable cost per unit. So I do that formula here. Very simple formula. So I do here is equal to this is equal to Q, which is 0, multiplied by variable cost per unit, which is this. And the variable cost per unit, the cell should be made an absolute cell reference. So I do enter and drag all the way from 0 to 1,000. And that should take you a few seconds. Right. Contribution. In the main lecture, you'll get a full explanation of the meaning of contribution. That terminology is coming from marginal costing. And I did a brief lecture on marginal costing inside that main lecture, CVP lecture. So do well to listen to that lecture, to watch that lecture, and pay attention to the details in there, because you'll be examined as part of what you'll be examined on in the exam. Okay, so contribution is selling price minus variable costs. Contribution per unit is selling price per unit minus variable cost per unit. Total contribution is total sales revenue minus total variable cost. So contribution per the model we are doing is simply revenue minus variable costs. That gives us contribution. So this is equal to this minus this. And I just drag, and that's the beauty of doing formula work in Excel. I just do one formula, drag across the rest. So up to 1,000. Yeah. So this is contribution across all the quantities. Now fixed costs. Fixed cost is given as this, 20,000. So I just refer to that value and drag. So fixed cost is constant, 20,000. Wow. Okay, so now see what is happening. This is the formula. Cell B9, this place, I made it equal to B3. And I dragged. But when I dragged, okay, in cell B9, it is 20,000, all right. But C9, D9 is showing dash, 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 dash. Who can tell us the reason why it is showing these figures instead of showing 20,000 across all the quantities? Who can say something about it? Okay. The reason is that I should have made this cell reference an absolute cell reference, because when I drag, I want it to just copy the values from that cell. It shouldn't drag, it shouldn't move from that cell to other cells. Okay, so we need to modify the formula here. Just change this one to absolute cell reference, that's all. And then redrag to correct the initial error. Okay, so 1,000. And we should have 2,000 over. Okay, so now total cost. Total cost is equal to total variable cost plus total fixed cost. So this is equal to total variable cost, this one, plus total fixed cost, this one. Let's do that. Let's drag across up to 1,000, quantity 1,000. Okay, so we have the total fixed cost at any level of output. At output 0, total fixed cost is equal to, total cost is equal to total fixed cost because there's no variable cost. Output 10, total fixed cost is, total cost is equal to total variable cost, which is 600, plus total fixed cost, which is 20,000. So we have 20,600. And it calculates it perfectly for all the other quantities. Then operating income. Operating income, also known as profit before interest and tax, is computed as, it's simply your profit, which is your revenue minus your total cost. Profit is equal to revenue minus total cost. So at output level 0, your profit is equal to your fixed cost. In fact, you make a negative profit. You have sold nothing. You have made no revenue. Yet, you have incurred fixed costs. You have also not produced to incur any variable costs. So output 0, your operating income is negative 20,000, which is the same as your fixed cost. Let's drag across all the quantities and see the picture. As we are selling, what is the picture of our profitability? And that's the kind of picture we want to portray in this kind of analysis. Okay, so when we sell 0, this is our profit, negative 20,000. We sell 10, our profit reduces from negative 20,000 to negative 19,600. We sell 20, profit reduces further. Sell 30, sell 40, sell 50, 60, 70, 80, 90, 100, 200, 300, 400, 500. We are selling 600. Sorry. When we sold for up to 400, then we realized something with 500. At 490, our revenue, we were still making losses. Sorry, our operating income, which is our profit, was negative 400. When we sold 500, our profit was 0. So that tells you that at sales output of 500 units, we generate enough revenue to pay all of our expenses, both fixed and variable, but nothing will be left. So you see your income to be 0, your operating income to be 0. Beyond output or sales volume of 500 units, you begin to make what economists call supernormal profits. So 510, we make profit of 400. 520, we make profit of 800, and so on and so forth, up to 1,000. So if our budget is to sell 1,000, if we sell 1,000, we will make a profit, operating income of 20,000. Okay, so this is how Excel will help you to kind of picture. And the interesting thing about Excel is that it gives you the flexibility to experiment with large quantities of sales volumes. I mean, different levels of sales volume. Like in this place, 0, 10, 20, 30, 40, up to 1,000. We can even extend it to 10,000. And it's just about dragging. Few seconds, you are done. So you can just simulate, just kind of experiment and really get what will likely happen in your business or what is actually happening in your business. It's a very good tool to use in every business, big or small. And your learning as students should involve using these tools. You don't just need to concentrate on grade. Grade brings nothing, I'm telling you. Knowledge is what brings everything. You can make grades without having knowledge. That is very poor. There are people who have never been in school. In fact, they have no knowledge of grades. They have never made grades. But they are the people creating the jobs for you to be employed. Have you thought about that? That should tell you grade is not a big deal. It is knowledge. Okay, so we have understood how we can use spreadsheets to model cost volume profit analysis. We capture key input variables here. This is our output. Remember, cost volume profit analysis wants to assess the relationship between our cost structure as a business, the volume of sales, and profitability. the linkages between these variables. That's what we are assessing. So with this given information, with a given cost structure, given sales revenue, what is the impact on our profitability at various levels of sales volume? Very beautiful. So after doing this analysis, all of these are figures. You should be able to see the figures in graph. And that's what most executives use for decision making. It gives you the bigger picture without looking at details. You just get the overall picture. And if it warrants that you go and look into the details, then you come to the figures. So at this point, we are going to kind of create a CVP graph based on this data and see how it looks like and what information the graph give us, what the graph communicates to us. Okay, so the main relationship is your revenue and your total costs. How are they relating? So at what sales revenue are you making losses? At what sales revenue are you making profits? And at what sales revenue are you making zero profit, and at what sales revenue are you making above zero profit? Okay, so let's try to do that chart. So pick this whole range for total revenue. Okay, so this is selected, and let's also select total cost. These are the main variables that will show the impact, even though we can pick other variables in addition, and we'll do that later. So for now, let's control select total cost. Okay. If we just do a graph on these two variables, we will see the picture that the figures are communicating in graph. So let me just do a line graph. Okay. So what I can do is let me move the charts into a separate sheet so you can see things well. Okay, so this is the chart. The blue line is total revenue. The orange, or if you like red, is total cost. So you will see that, and this one is a level of quantity. Of course, it is scaled. You will see 1, 3, 4, 5, 6, 7, 8, 9. 1, the interval between them is scaled, and we need to know about the scale it is using. But the picture I want you to understand is that at certain levels, at the lower levels of sales volume, you see that the total revenue curve, the blue curve, is below the orange curve, the total cost curve. In other words, the total cost curve is above the total revenue curve. And from your economic studies, that tells you that total revenue is smaller than total cost. Or if you want to speak it in the reverse way, total cost is bigger than total revenue. If total cost, which is represented by the orange line, is bigger than total revenue, then you are making a loss. Your cost is bigger than your revenue. So the whole of this place where the orange line is always lying above the blue line, they are all loss-making region. So loss region. And this continues up to a point, at this point. And this point corresponds to what the figure, the calculations showed us. The point that we had 0 net income here corresponds to 500 units. We have 0. At this point, our total revenue of 50,000 is equal to our total cost of 50,000. So revenue is equal to cost, nothing left as profit. Profit is 0. This is break even. This is what we call break even point. So at this point, we can get various things. We can get the break even quantity. Break even quantity, you can represent it as BEQ. We can get the break even revenue. You can call it BER, break even revenue for short. And you can get the total cost at which we break even. And of course, once it's break even, total revenue will be equal to total cost. So that is just common sense thing to note. So this is what the information is telling us. Break even quantity because profit is 0. So the quantity that corresponds to this 0 profit is break even quantity 500. The revenue that corresponds to this 0 profit is break even revenue. And you should be able to read the same thing from the chart. So from the chart, the meeting point, the point where total revenue is equal to total cost, 50,000, 50,000, is the break-even point. So when you trace, this is using a scale. So the numbers below need to be multiplied by the scale it is using. So it's around here between 49 and 51, which will be 50. So I think it's a scale of 100. So 50 times, it's a scale of, I think, about 1,000. 50 times 1,000 will be 50,000. Okay, so this is how you trace it. This is the break-even point. Break-even point. If you trace the break-even point to the quantity axis, any quantity you pick here is the break-even quantity. If you trace this to the revenue axis, any value you pick here is the break-even revenue. So you have to note that this axis, the vertical axis, is for revenue, and the horizontal axis is for volume of sales. So the vertical is for revenue and cost as well. So the vertical axis is for both revenue and cost. So if you trace here, you get the break-even revenue. If you trace here again, you get a break-even cost. They converge. They are all 50,000, 50,000. That is why the profit is 0. That's why the profit is 0. And if you trace down here, you will get the break-even quantity. Beyond the break-even point, all of this region represents, well, let me use a different color. All of this region represents profits. Profit above 0, supernormal profit in terms of economics. So this is profit region. And how much profit at each point on the quantity axis can be ascertained. You just trace from here up to, if you trace up to the pink, sorry, the orange, that is giving you the costs, the total cost at that quantity. If you trace it up to the revenue line, that gives you the total revenue. And you always realize that the total cost will be below the total revenue, and the difference represents your supernormal profit. In an exam situation, you could be given a chart like this for you to interpret. So you have to watch this video and make sure you understand. You can read from other sources, watch videos that other people have recorded if you think you need to do so. If we want to add other inputs, other variables to the equation, we just did a total revenue, total cost. You can also do, so let's pick other things and see. We can experiment, with many things. So total revenue, let's select total revenue. Select total variable cost. In fact, you can just do whatever you want to do. I'm just experimenting with how the graph will look like. The total variable cost. I'm going to select total cost. Okay. Okay, so now let's insert a line chart based on the selection. Right, so let me put this in its own chart sheets. Okay, so this is the picture. This is the new graph. And let's read the legend. Blue line still represents total revenue, but this time round, the orange line is total variable cost. So you always have to read the legend because it's explaining the color coding. The ash line is total cost. So again, the same thing we did previously, which was total revenue, total cost. That is what you are seeing here. That's what you are seeing here. So this is the break-even point. And all of these, where total revenue is lying below total cost, is the loss region. This is the profit region. Now the addition is the total variable cost. Now I want you to see something. See the relationship between the ash line, which is total cost, and the orange line, which is total variable cost. You will see that the distance between those two lines are always the same. So they are like parallel lines. All right. It's parallel, telling you that the distance between them is fixed. And of course, the difference between the ash line, which is total cost line, and the orange line, which is total variable cost line, is total fixed cost. Because total fixed cost is fixed, that's why you are seeing the relationship between the two lines as parallel lines. So this represents total fixed cost. And I can just take a shot of this and ask you to interpret, ask you various questions. So I have done my job to educate you on what it represents. You should also do your job to go and read to understand it. All right. Okay. So I think this is where we will end this brief lecture. What I want you to do is to pick the same, try to create the same data set as I have used, and go through the same steps I went through to try to create this model. After that, try to think of your own data, just experiment with data and try to model based on your own data. That will give you an added understanding. Then you begin to get the whole analysis from a more practical perspective. If you do that and you have questions, you can channel the questions to us in the office. Okay, thank you very much for your time.